Well, a pleasure to be here, and merci beaucoup Dassault Systèmes et l'Institut Pasteur. Mon français c'est un peu cassé, mais le titre c'est la nouvelle ère de robotique humanoïde, the new era of humanoid robotics. And I want to mention first that part of my role, aside from being faculty, is being the chair of good systems. And that's part of a larger question as a scientist of ensuring that we address questions on privacy, safety, and the labor dynamics as well, which are major concerns in robotics. At the same time, we have really a new environment and this sort of paradoxical time where humanoid robotics are thriving, and there is hundreds of millions Series Bs and Series Cs being invested in cutting-edge robotics companies, humanoid robotics companies, and I want to explore why this is happening, in part because we're fulfilling 3 of the rules of the principle of robotics, which is speed, accuracy, and repeatability, but we are starting to fulfill 2 more principles, which are intelligence and safety, and I would say that the principles as well of economies of scale are kicking. For instance, if we do a little bit of sort of back-on-the-envelope calculations, a car is sold, let's say, for $40,000, and about 25% goes into manufacturing, so let's say 10,000. It contains 1 ton of metal, including aluminum 1101 and stainless steel or carbon steel, and those run for about $2 per kilogram, so we're talking about $2,000 in metal. Now, half of the costs are in the bill of materials, so we're down to $5,000 of the bill of materials of a car. And out of those numbers, about half is metal. So what I'm trying to say here is that there is a kind of a convergence of machines towards the price of metal. And if you think about a robotic system, it contains about 20 to 30 times less amount of metal because it's very small, it has human form. Instead of weighing a couple of tons, it weighs just a few kilograms. So we're going to see a kind of a descent to the bottom where the price of robotics, and yes, including humanoids, is going to be very cheap. And these kind of 6 principles are fueling this race for the general purpose humanoid of the future. Was that a bit too long? Let me introduce myself. I spent my career, 25 years, building robots for Honda in Japan, and then for the US Navy, and I'll talk about it, and then for NASA in particular. Those are the main drivers of humanoid robotics in the US. In here you see I work in all the stack of robotics, from the design of liquid-cooled viscoelastic actuators, as we see here, to the design of teleoperation. Here we see some of the most advanced teleoperation maybe 6-7 years ago. Now things have changed with supervised learning and some of the reinforcement learning that is showing up in generative AI, obviously. And that has allowed me to build a laboratory called the Human Centered Robotics Laboratory. Maybe foremost is here on the right side, we see Apollo. We spin off a company in 2016, and now is moving, it has 150 employees, it's moving to 300 employees. I will not talk where the funding comes from, but it's pretty large to give you an idea of the excitement that there is. And I think that there was a question about what is an engineer. I say that mathematician is somebody, or it is said, that transforms coffee into equations, and an engineer transforms equation into money. Not because we want to make money, but because we want these systems to be commercialized and be out there in the wild. This is very much empowered by research in the past by NASA, but nowadays by the US Space Force. The US Space Force is a new entity in defense. It's spending a lot of money into very kind of Star Wars kind of looking like things that are becoming real. I'll talk briefly about it. And then also the use of supervised learning techniques, in particular behavioral cloning, imitation learning, that I'll show on the right side. That without ignoring the the community factors, how from a psychophysiological perspective people feel, from a sensor perspective, a physiological sensor perspective, and from a communication psychological perspective. And of course, the ability of building anthropomorphic robots is becoming more and more important. Kudos to Nancy in France for organizing this year in next month, the Humanoids 2024 conference. I was the general chair of the 23 Humanoids conference IEEE in Austin. You can see here the video of the organization. There was such a sort of incredible environment, such a sort of reinvigorating, and you can see palpable the Poles, the Chinese, US, Europe Poles showing up and trying to create a market in these domains. So you had the time, enroll, register, and attend Nancy. Lots of party. That's what the students like. All right, so I'm going back to really my early career in 2008, 2009. I used to read often the National Intelligence Council, US, where they make predictions, in this case a prediction of 2025, so this is 17 years ago. And interestingly, these are the 6 technologies that we're predicting that today that will be the most hip. That includes biotechnology, which is the science of aging, the technology for aging. It includes a couple of items in energy and service robotics and the Internet of Things. I think to a certain extent, this is sort of the killer app for robotics, if you will, but with caveats because we're not quite there yet. Interestingly, no AI and ML, how short-sighted we were. I mean, it was completely ignored. It's impossible to predict. None of us can predict what will happen in 17 years from now. I bet you, okay? We're going to revise these slides on time. I was also motivated by some of the numbers from the rehabilitation industry. This is a study by Apptronik, a Spanish company in 2007. By age 80, unfortunately, many of us will be immobile. Arthritis, musculoskeletal diseases, cognitive impairments, and so on. Lifespan in France is 86 for women, 80 for men, and by 2100 we'll have 1 billion age 80 plus. This is the killer app of these service robots, these humanoids, these exoskeletons, but we're not quite there yet. Exoskeletons have been a rough road. This is an exoskeleton that I designed together with the company Apptronik. We killed the project. We unfortunately lost it to France. France has the best exoskeleton in the world by a company called Wondercraft. Anybody from Wondercraft here? You're to blame. But in here we focus on the symbiosis of the neuromuscular behavior and the real-time controls, the comfort of wearing them for augmentation or for balance operations. For that, you have to deeply understand the real-time, not the offline behavior, not the simulation, but the muscle-in-the-loop sort of behavior. And it turns out that muscles don't behave as linear second-order systems, as you see here, the Laplace transform, but here in gray, they behave as hysteretic damping behaviors. You see that the damping, it is a pure imaginary term. It's actually non-causal, but there is a way to kind of hack the inverse and obtain a temporal equivalent. You can design controllers, and those are equivalent to the graph on the upper right. You have this hysteresis, which is a hysteresis on the impedance of the muscles as a function of positions and velocities. And interestingly, we don't have this kind of viscous behavior. We have this kind of change of stiffness that dissipates energy. That allows the human body to have a very special characteristic, nonlinear behavior, and allows to be very invariant to the loads that we pick. We're very special devices. But then when we connect machines to us, we must understand the high-frequency behavior in order to have a great symbiosis, real-time behavior of the wearable systems. talking about wearables, work that I do with Professor Nanchu Lu. We're designing together electronic tattoos, EEGs, electrodermal activity sensors, ECGs, and all of that, we are on the process of having them as part of the feedback loop in the real-time systems because these wearable machines are taking decisions for us. So given all this perspective, it seems that the killer app for humanoid robotics would be assistive behaviors. Here we have a vision of Honda and myself in 2009. And here in We Robot from Tesla, we have a more recent embodiment of that vision. But the truth is that the money is, the hard cash is in these lean manufacturing applications. That's where humanoids are making an impact and where the Series Bs and Series Cs are growing. But who has really truly funded humanoids over the decades? Well, in the US, foremost is the Office of Naval Research, the Cognitive Science program, where they put together cognitive scientists, computational linguists, and roboticists in order to solve this problem of automating ship tasks. Why they are interested? They're not interested in automating only. Sailors and officers, they stay in vessels for a few years, but not forever. And vessels stay there for decades. Knowledge is forgotten. Nobody remembers how to repair that diesel engine. We see robots, the Navy sees robots as holders of institutional knowledge, that they onboard themselves, they communicate, and they collect information long-term of the institution as a whole, the hierarchies, the operations, as well as the minutiae of how to deal with every single machine. So now, 4 years later, you can go, and the robots are the keepers and the institutional knowledge, if you will. The other institution is NASA, in particular Johnson Space Center, which I have worked and consulted for them for many years, and JPL, Jet Propulsion Laboratory, now in partnership with the new Space Force. You see here some of these Star Wars kind of behaviors for servicing satellites in space, as well as thriving robotic programs. So where is the money coming in, and what is the kind of the demographics of that money? Well, here we have 10 humanoid robotics companies, one of them in Europe. We have a few in the US, a few in China. And those companies, they are on Series Bs, most of them, 100, 200, $300 million. About 200 employees. My company is Apptronik. I didn't put the numbers because it's secret right now, but we are growing to 300 people. But really, the winner of all of that is Amazon and Ocado and other places where warehouse robotics is today, where the hard cash is, but only for now, okay? Because these are special purpose robots. I'm gonna argue that general purpose robots is the same way we're looking for general purpose sort of multimodal machine learning are gonna make more strides. So in a recent panel I chair for with Amazon, we were pondering what has made so successful Amazon, and the answer is this report about humanoids for Morgan Stanley, where that the technology adoption models with a 30 trillion global labor market, which is the whole labor market, that's what we are addressing, and the accessibility through mechanization and through generative AI is now open. That's really why this success is happening. So here we see some of these numbers, also from Morgan Stanley. Labor is 30 trillion. In 2040, we'll have 8 million humanoid robots. By 2050, we'll have 60 million humanoid robots. The technology adoption models of Morgan Stanley predicts a 3 trillion market. So that's a market we're predicting for humanoid robotics. Digging deeper, above is the same 10 humanoid companies. Below, we have truck loading companies, Covariant, Dexterity, Berkshire, Mugin, Boston Dynamics. They have similar size. They have similar funding rounds. Maybe the big difference is that the truck loading companies, they are making exits. Here I have a mistake. It was not Covariant. It was another company that exited to Intrinsic already. We have exits to SoftBank, 375 million. We have access to Hyundai. So we're seeing small successes that perhaps we're going to see this more in the whole human-centered robotics market. So overall, I wanted to just emphasize that the foundation principles for this growth is because of the speed, accuracy, repeatability, intelligence, and safety. Okay, just a quick break. Going fast. Okay, so to continue on, what makes special humanoid robots? This is a segment from Boston Dynamics Atlas in lean manufacturing. And you can see these pendulum dynamics, these very quick turns. When we go to a barista in Italy or here in Paris, we don't expect them to kind of go slowly and take 20 minutes producing espresso, right? They move like the speed of light, right? They play basketball in the court of the coffee machine, okay? That's what we are expecting from these robots. And humanoids, they are like a big center of mass on a stick. These are these kind of very rapid movements that we play when we play basketball. These are exponential dynamics. Here we have the linear system. U is the position of the feet. And then we can see these hyperbolic cosines, which are exponential. So if we translate, well, that has impact on safety. And you can see in all of these videos, what you see with humanoids is that humans are always next to humanoids. We don't see that with other robotic systems. I wanted to emphasize that safety dimension. The video, this 2017, in my lab was the third in the world to achieve unsupported line fit walking after Boston Dynamics, U Michigan, and Agility Robotics. Here is 2024, Deep Robotics is making an impact in a way we solve this problem. But especially going to the speed, if we do a comparative with the Tesla car, accelerates at a portion of a g, a constant acceleration. If we visualize that, humanoids accelerate with exponential accelerations, displacements, if you will, whereas cars and wheel robots displace with quadratic displacements. So this gives a key advantage for humanoids. This is exemplified here. There is no wheel robot that will fulfill these demands. It looks like a joke, but that's my expectation of humanoids operating in a factory. And that's what I think is the killer app today. I think that lean manufacturing is going to be where we're going to see them. There's operating very fast in a smaller space. If we go to the principle from Japan, from Toyota's success, reducing waste, temporal and space waste is very important. And I don't want to see humanoids as a replacement of human labor. I want to see them as an enhancement of small and medium enterprises. 30% of the businesses are manufacturing. 50% of the economy of manufacturing is from those small businesses. Many of them, they never happen because there's a couple of students from École Normale, they want to make a company and they don't have enough personnel. So these general purpose robots will allow them to scale operations for everyone, the educated, the young, the old with less resources. That's where I see the application of humanoids. And I'm going to skip, there is learning we do in the job as well, but I think with 7 seconds, I'll skip it. Learning on the job is very important. This is supervised learning for dual hand manipulation that we perform. We build these wearable devices. I compare that to the new cell phone. Your next cell phone is going to have a hand on it, okay? You're going to go walking and you're going to be talking to it and showing, and that's the way we can ground movement into semantic meaning, okay? I'm just joking, but institutional knowledge is going to be very important, and grounding through a speech is going to be very important. More stuff, mechanical stuff, and finally, what's up with the tax that all humanoids look they're wearing tuxedo? Anybody can respond to that? Thank you.
wasn't expecting the text conclusion. Thank you very much, Dr. Sentis. I have a question for you. We hear, of course, a lot about robotics, and especially with the Tesla one, I mean the Musk one. What are, in your mind, the biggest challenges in the next 2 to 3 years? I mean, are we really going to have an iPhone moment for personal robotics? Where is it in the future? When is it in the future?
Yeah, I think personal robotics, there is a high demand at home, and in particular with the aging population. That's the killer app really with we're trying to go. I think penetrating this market is very, very difficult because you're entering almost the area of consumer electronics. The cell phone at the beginning was a luxury item, maybe something for bankers, and then it penetrated. Now you go to the poorest countries, and everybody relies on the cell phone. We're expecting to see the same. I wanna think that the future humanoid robot running at about $5,000 of pricing is going to be the enabler for home care and for small businesses everywhere. But home care in particular is going to take some time. Where we're seeing the economies of scale is in manufacturing. We see all the manufacturing, all the Mercedes, all the BMWs, Hyundai, all of these companies are jumping, logistic companies as well. And then also what we're seeing where the money is coming from is from companies wanting to gather data. I know it sounds crude, but when you have these robots in your environment, right, you have access to new data. Hopefully, our job as institutions is to ensure that this data is used in a positive way, just like the World Wide Web, when it was established as a consortia, it was used in good ways. So that's where I see the next markets.